Imagine staring at an ocean of data, billions of points, each one a mystery. No labels, no explanations, just raw information. For us, it's a chaotic expanse, an insurmountable task. But what if machines could not only navigate this chaos but discover profound, hidden order within it? For centuries, human analysis has relied on structure we impose. We categorize, we label, we define relationships. But what happens when the sheer volume and complexity of data outstrip our capacity to predefine? We miss the subtle patterns, the emergent properties, the insights lurking just beneath the surface. This is where the discovery engine comes into play, a realm of artificial intelligence known as unsupervised learning. It's a paradigm shift where algorithms become autonomous explorers, sifting through the seemingly random to unearth intrinsic structures and relationships that no human might have ever considered. Unlike supervised learning, which requires meticulously labeled datasets for training, unsupervised learning throws algorithms into the deep end with raw, unclassified data. It's like handing a child a pile of mixed toys and asking them to sort them into groups without telling them what a car or a block is. The magic lies in the algorithm's ability to perceive inherent similarities and differences. They don't need to be told what to look for, they build their own understanding of the data's landscape, carving out meaningful distinctions from apparent homogeneity. One of the most intuitive forms of this discovery is clustering. Think of it as the art of grouping. Given a massive collection of unlabeled customer data, purchase history, browsing habits, demographics, a clustering algorithm can identify distinct segments of customers who behave similarly, without any prior definition of what those segments should be. A common technique is k-means clustering. It iteratively assigns data points to clusters based on their proximity to a cluster's center, then recalculates those centers until the groupings stabilize. It's a process of refinement, drawing boundaries where none were explicitly drawn before. The applications are vast. Market segmentation for targeted advertising, identifying communities and social networks, detecting anomalous network activity indicative of cyber threats, or even categorizing astronomical objects based on their observable properties. It unveils natural groupings that are invaluable for strategic decision-making. Then there's dimensionality reduction, another cornerstone of unsupervised learning. Imagine a dataset with hundreds or even thousands of features for each data point, a dizzying array of numbers. Humans struggle to visualize or comprehend such high-dimensional spaces. Dimensionality reduction techniques act like a master cartographer, distilling complex, multifaceted information into a simpler, lower-dimensional representation while preserving as much of the original data's essential structure as possible. It's like taking a 3D object and projecting its most important features onto a 2D plane. Principal Component Analysis, or PCA, is a prime example. It identifies the directions in the data that account for the most variance, effectively finding the principal components that capture the most information. By projecting the data onto these components, we reduce its complexity without losing its core essence. The benefits are transformative, reducing noise in datasets, accelerating other machine learning algorithms by simplifying inputs, and crucially, enabling stunning visualizations of complex data that would otherwise be impossible for the human eye to process. It allows us to see relationships in data that are hidden in higher dimensions. When clustering and dimensionality reduction are used in tandem, their power multiplies. We can reduce highly complex data into a manageable form, then cluster it to reveal inherent groupings, offering a multi-layered understanding of the data's underlying organization. It's a journey from chaos to an elegantly structured cosmos. Unsupervised learning isn't just a technical advancement, it's a new frontier in discovery. It empowers machines to transcend human biases and limitations, to listen to the whispers of data itself, and to reveal the hidden orders that govern our world. It's the ultimate discovery engine, constantly illuminating the unknown,